Hello, it's Sebastian Danicic again. Now I'm going to tell you about lists. So this is the week one subject. So lists are very similar to vectors, which you've looked at already, and which are also fairly similar to arrays. Lists, like vectors, are dynamic. That means you don't have to decide beforehand how many elements these lists are going to have. So they're very useful in situations where your data is going to grow or shrink in size without you knowing beforehand how many elements of data you're going to need. So when you get given new Java data structures to look at, the first thing you should do is go to the Java API documentation, and what I've given you here is a link to that documentation. So what you should do first is click on this link and see what it tells you. So here we've got the usual thing. Here we've got a class array list. Here it tells us all the interfaces that it implements, and then here we've got some things you can read about lists. So I suggest you read this. But the important thing to look at are the methods in the class array list. So here we've got three constructors. One with where you have no parameters at all. That's for constructing an empty list. Here is one where you can construct a list from another collection that you've already got. A collection could be a list or some other thing like a set, which we'll come on to later in the course. So here you can construct another array list from a list that you've already got. So when you use a constructor, don't forget you say new array list or new array list and giving it another collection. And the last one here is when you want to give it a different initial capacity. I don't use that one. So here, so having done the constructors, we then look at the instance methods that we've got. So they're all the useful things that you'd expect, but obviously you should look at these before you start trying to use lists, because it's these methods which really define what you can do with a list. So here, for example, we've got one called add, and it takes an index and an object, and it inserts the specified element at the specified position in this list. Here's another one called add, and again this appends the object to the end of the list. So here this one only has one parameter because we don't need to tell it where to put it, because it knows to put it at the end of the list. So if we give it a parameter, an integer, it puts it at that position. If we don't give it a parameter, it knows to put it at the end of the list. Here's another useful one. Here, if we've got this one's called add all, and what it does, it appends a collection of elements, which could be another list, to the end of the list to which we're applying add all. So if we say l.addall_m, it'll create the list which has got the elements of L at the beginning and the elements of M at the end. We'll come on to that later when we do some examples. Similarly, we can insert a collection of elements starting at a particular point in a list. Here again, add all has got two parameters, an integer and a collection. What I suggest you do with these things is try them out. That's the only way to find out what they do. So here we've got another useful one here, contains. It returns true. We give it an object as a parameter, and it returns true if this list contains the specified element. And obviously if it doesn't contain it, it'll return false. Get is another useful one. That returns the element at a particular position in the list. So we say get 5, l.get5 will return the 6th element of the list. Because lists are like vectors and arrays, is that the index starts at 0. So get l.get0 will return the first element of the list, which we call the 0th. Now we can do it the other way around. We can give it an object and it'll find the occurrence of the position of the first element in that list. So we say index of searches for the first occurrence of a given argument, testing for equality using the equals method. So notice it can only do this if the objects you give it, if Java knows what it means for two such objects to be equal. We can test whether the list is empty. We can find the last index of a particular element. So, so that's the equivalent to, that's the opposite of this one. This one finds the first, and this one finds the position of the last. We can remove an element at a particular position in the list. We can remove a whole range of elements. We can change set. We'll change the value of an element. It'll replace an element with a different one. So if we say set 3 and O, it'll replace the thing at position 3 with O. We can find the size of the list. That's useful. We can convert a list to an array, etc. So in the next video we'll be trying out some of these methods, which is something I suggest you do too.